In this video, we will be applying oxidation numbers to a balanced chemical reaction in order to A, identify when we have a redox reaction, and B, to find out what's happening to the electrons. We are on page 7 of your notes booklet. So remember that oxidation numbers are a way of keeping track of gain and loss of electrons. Let's start off this section by writing a chemical equation for the following sentence. Sodium reacts with chlorine to form sodium chloride. Please pause the video, write a balanced chemical equation, and write the oxidation numbers above the substance. Remember that when you write a formula for anything in the Hofbrinkel, it needs to be something 2. Once you have the correct formulas, then you can balance. And you have a ratio of 2:1:2. Now you need to write oxidation numbers above the substance. What we see here is that sodium starts off with an oxidation number of 0 and ends up with an oxidation number of +1. This is because sodium loses 1 electron and chlorine gains that electron. In the formula NaCl, we acknowledge this by writing a +1 for sodium and a -1 oxidation number for chlorine. If we take a look at the equation, we see a change in oxidation number between the sodium that we start off with here and the sodium ion that we finish off with here. This helps us to identify that there is indeed a redox reaction, which means there is an exchange of electrons. Let's do a table. Here we have sodium. Our initial oxidation number in the formula is 0. Our final oxidation number over here is +1. If something goes from being a neutral atom to a +1, that means it has lost 1 electron. And it has been oxidized. Remember oil rig, or Leo says grr. Chlorine starts off with initial oxidation number of 0. It becomes -1 because it has gained 1 electron. Gain of electrons is reduction. To identify if a chemical reaction is a redox reaction or not, we need to first write out the oxidation numbers for each substance in the balanced chemical equation. If there is a change in oxidation number between what you start with here and what you end off with on the right-hand side, then we classify that as a redox reaction. If we compare the oxidation numbers before or in the reactant side and the product side, and we see that the oxidation number increases, it's oxidation. If there is a decrease in oxidation number, it indicates reduction. What I like to do is a bit of an integer line at the top of my notes when I'm working with oxidation numbers. So I'm just going to draw out a number line here. So if we start at 0 and we increase an oxidation number, that is oxidation. If we start off at 0 and we decrease, that indicates reduction. So a number line like this can help you quickly identify whether or not there's oxidation or reduction happening. Now it is your turn. You have a balanced chemical equation for the formation of magnesium oxide. You need to determine the oxidation numbers for each substance in the compound and complete the chart below. Please pause this video and give it a try. Both magnesium and oxygen start on their own and they will have an oxidation number of 0. Magnesium in an ionic compound has a 2 positive charge, therefore its oxidation number is positive 2, and of course oxygen is negative 2. If we tabulate down here what's happening with oxidation number, we start off with a 0 as magnesium's oxidation number. It's positive 2, so that means it's going from 0 up to positive 2 here. That means that it is losing electrons. Specifically losing 2 electrons, and it is being oxidized. On the oxygen side of things, we see oxygen starting off as an atom and becoming an ion by gaining 2 electrons. And therefore we say that oxygen has been reduced. An important reminder, reduction and oxidation occur together. If something loses electrons, something else must gain the electrons. In order for something to gain electrons, something else has to part with those electrons. You need both. We're going to now encounter 2 new terms. Agents, reducing agent, abbreviated as Ra, and oxidizing agents, OA. A reducing agent causes something to gain electrons, so it acts on a reducer, versus an oxidizing agent causes something to lose its electrons. Pardon me. Yes, an oxidizing agent causes something to lose electrons. So if we look back at the previous example, we saw that oxygen was a substance that was undergoing reduction. Therefore, we say that oxygen is the oxidizing agent. Magnesium is a substance that is oxidized. Therefore, we say that magnesium is the reducing agent. In practice problem number 2, we go from start to finish. You have an equation there. Make sure that you balance the chemical equation always. Determine the oxidation numbers for the substance. In the chart below, identify the element, its initial oxidation number, final oxidation number, change in electrons, identify it's been oxidized or reduced, and finally, determine if it's a reducing or oxidizing agent. Please pause this video and try the question. In this reaction, we can see that the 2 substances that are changing oxidation numbers are zinc and one of the nitrogens. So we're only going to deal with the substances that change oxidation numbers. The initial oxidation number for zinc is 0. It becomes positive 2. Therefore, it has lost 2 electrons, which means it has been oxidized, and it is the reducing agent. The nitrogen that is in this compound and this compound here has started off at positive 5, decreased to positive 4. It has gained 1 electron. Therefore, it has been reduced, and it is the OA. Here is one more practice problem. Similarly, you're going to determine the oxidation numbers for each substance in the balanced chemical reaction, and then you're going to create a summary table of the substances that are changing oxidation numbers, identify if it's been oxidized or reduced, and finally, determine which agent is which. Please pause this video and try this question. In this reaction, nitrogen starts off with an oxidation number of 0, becomes -3, which means it has gained 3 electrons. It is reduced, therefore it is an oxidizing agent. Hydrogen starts off with an oxidation number of 0. Its final oxidation number is +1. It has lost 1 electron, therefore it is oxidized. This makes it the reducing agent. This is the end of the video. Please proceed to work on assignment 3.1.